Optimizing performance in React is a topic that has been covered very extensively ever since the inception of React itself. I mean, if you do a quick search on how to optimize the performance of a React application, you're going to find a bunch of videos, tutorials, guides on how to do it and how to follow the best practices to keep the performance optimal. The thing is, however, React is not the same as it was many years ago when a lot of these guides were created, right? React has evolved, and naturally so. Now we're in something that we call modern React, right? Where it's no longer just a simple client-side focused library to build user interfaces. It now extends much more than that. It goes on the server, we have new APIs, we have new ways of doing things, and a lot of these performance optimizations that previously were the most important are no longer. So in this video, I want to give you updated information on how to improve the performance of the modern React applications. In this video, I'm only going to give you a couple of tips that are going to be super important, but I've also gone ahead and compiled a free guide of a bunch more equally important tips that I'm offering to you completely for free. To get it, the only thing that you have to do is join the Import React newsletter, which is completely free and it's great value. If you use the link in the description below, the first link, as soon as you join, you're automatically going to get sent the performance optimization guide. So if you want the guide, click the first link in the description. Now let's get into the video and let's talk about performance in modern React. Alright, so let's begin. Let's talk about performance optimization in modern React. The first tip that I'm going to give you is the one that is the simplest to set up while having the biggest value that you can have across the board, no matter what kind of application you are building. And that is going to be to install and integrate the React compiler into your application. The React compiler, if you somehow haven't heard about it already, is essentially a way for you to not have to write use memo, use callback, to not worry about memoization across your entire application anymore. The React compiler is a simple thing that you can integrate into your application that is going to do all of these things for you automatically, and you don't have to worry about it at all. Now, this is really important because if you look at other performance guides, right before we had the React compiler, the first thing that they would always tell you would be to memoize your things in React. Memoize components, memoize values, and memoize functions, right? Use things like use memo, use callback, and so on to prevent unnecessary re-renders, because that's a huge bottleneck if you don't do it correctly. With the React compiler, the same concept still applies, right? You still want to memoize things, but instead of you doing it yourself, you let the compiler do it automatically for you across the board, right? So that's a huge benefit. Also, something that is not talked about enough is the fact that this does it automatically for you, right? It's code, right? It just scans your entire project and just applies it and compiles it basically to automatically memorize it behind the scenes. Because it does it automatically for you, that means that it will do a much better job than you could possibly hope to do, usually in most cases, right? Because the reality is, when you're writing use memo and use callback, it's actually not that simple. Using these things, using these hooks requires you to know and understand what memoization is, when it makes sense to use memo and use callback, because you shouldn't use them all the time, and also understand the trade-off, because using these is actually not free, and in some cases, if you use them incorrectly, you can actually reduce the performance. And then not only that, right, even if you know how to use them, maybe you might forget in some places, right, which is totally normal and totally expected. Or maybe the code changes at a later point, and now the use memo is no longer valid, and you forget to change it, or it's not obviously apparent that you have to do that, right? These are all things that, you know, could slip through the cracks if you do it manually. But if you use the React compiler, you have none of these problems because it's an algorithm and it essentially applies it to all of your code without you having to even worry about it. But there's also another benefit of using the React compiler that's actually not talked about enough, which is that the React compiler is not going to work. It is not going to memoize and optimize your components if you're not following the rules of hooks. Right? So in React, we have this thing called the rules of hooks, if you haven't heard, right? Which basically restricts how you're able to use hooks and the way that you're able to basically code some parts of the components. For example, right, you can only call a hook at the top level of a component, right? And you cannot call a hook conditionally, or you cannot call a hook, for example, in a for loop or inside of the JSX of the component, right? These are rules that as React developers, we have to follow. Now, the thing about these rules of hooks and just rules in general is that not everyone actually actually follows them because they're not strictly enforced. Yes, you might have ESLint in your application that is going to warn you whenever you're not following a specific rule, but React would still, in some cases, not in all cases, but in some cases would still work even if you're not following the rules of hooks, right? For example, if you're not providing every single dependency in the dependency array of a specific hook. And that is a recipe for introducing bugs in the application and also reducing the performance of the application. The rules of hooks are there for a reason. They make your application better and they make it follow the way that React was essentially intended to be used. And so what we have here is that previously, if you weren't following these rules, well, that was on you. You would have reduced performance and you would have some extra bugs in your application. That's on you to deal with them. Now, the compiler is actually going to bail out of optimizing that component if it finds and detects that you're not following the rules of hooks, which basically means that the React compiler is now forcing you, if you want all of its benefits, to follow the rules of hooks. It will tell you, it will scream at you if you don't, and it's going to wait until you fix it, and then only once you fix it and you're properly following these rules, then it will continue to actually optimize the component. And this is great because it reduces bugs and it increases performance, and it's honestly a no-brainer. Now, the second performance tip that I'm going to give you is ironically to move things outside of React whenever possible and whenever it makes sense. So what does that mean? What does it mean to move things outside of React whenever possible? It doesn't mean to ditch React and to use something else, right? That's not what I'm saying. All the haters, you can comment as much as you want. That's definitely not what I'm saying. What I'm saying is that React is made to build user interfaces, right? It's a library, it's a JavaScript library that helps you build user interfaces, and it excels at doing that. But when building user interfaces, there's often a lot of different things that come into play, right? For example, data fetching. Right? To build a user interface, usually you would need to fetch data from some place that is not going to be hosted in the application, right? So data fetching is something that we add on to building user interfaces and rather use to build user interfaces. And these are things that are not part of React directly. It's about those things that I'm talking about to try to move them outside of React whenever possible and whenever it makes sense. And here's why. Let's actually use data fetching because it is a really good example. Let's say that you have an application, you have a user interface, and you want to display some data that you're fetching from an API. Now, there's multiple places that you could fetch that data. If you choose to fetch that data in React, that means that you're fetching it inside of a component through useEffect or React Query or something similar, then that has a couple of drawbacks. The first drawback is that you essentially force the user to download the entire JavaScript bundle with all of the JavaScript code necessary, that is all of React, that is all of the libraries that you're using in case of React Query, for example, and have them download all of that before they can even begin to fetch some data in the first place. Obviously, that's inefficient, that's slow, and that can be avoided. So that's one thing. But then the second thing is that you're actually, by fetching your data inside of your components, inside of React, you're actually polluting the React component with data fetching code, right? Because to fetch data, you need to have the code enabled. Either you're doing this in a useEffect, which honestly you shouldn't, at least do it with React Query, but even then, you have to handle loading states, you have to handle error states, you have to handle optional chaining everywhere inside of your component because the data can be undefined, and you also have multiple re-renders as that whole data fetching process is happening, right? So this is inefficient, especially if it can be avoided. Now, how do you avoid this? How do you make this much more performant? Well, you would use a navigation library or a framework if applicable. If you're using a framework, use a framework. If you're using a navigation library, use a navigation library. Usually, the way that navigation libraries work is they're going to have a place for you to run some code before the component is even loaded. Oftentimes, before the JavaScript bundle of that component is even loaded in the first place. That is the place where you want to actually fetch your data and run all of your logic to provide the component, to provide the data rather, to the component that is going to consume it. Usually, that's going to be a loader, which is a function that you can run asynchronous code in, fetch all of your data, and then provide it to the component. This has a couple of benefits, right? First of all, you can actually load the data that the component actually actually needs at the same time that you're loading the JavaScript bundle for that same component, right? So it's actually faster for the user. And second, you can use that same loader and you can use the navigation library or the framework to actually handle your loading states, your error states outside of the React component, right? A lot of these libraries, they integrate really nicely with Suspense. You can show a nice fallback spinner, right? Some UI until the data is loaded. And then once your component actually has the data, or rather once the data has been fetched, the component can then be rendered and can have guaranteed that the data is going to be there, which then means that your component is simply just going to access the data from the loader, right, directly from the function or using the cache from React Query, for example. No longer needs to worry about any re-renders, no longer needs to worry about loading, no longer needs to worry about undefined or anything like that. And then it can just do its job, which it's really good at, which is to build the user interface using that data. Right? And doing it this way, fetching your data inside of loaders has a bunch of other benefits, right? It keeps your components super small, super easy to understand and to maintain, right? The code for them is really simple. And if you also follow things like the single responsibility principle, which basically you make extremely small components, they only do one thing, then you can actually build applications at scale super easily without having any sort of spaghetti code. And honestly, it's such a small thing to do, right? Because if you're building user interfaces, usually you would want to have different pages, right? There's a few applications that only need to have one page with all of their content. And so you're going to be using a navigation library anyways, right? So just use it for what it's good at, right? Put the data fetching in there and let React focus on what it is good at, which is to build user interfaces using the component model. And also just want to remind you, I only used data fetching here as an example, but there's other use cases where this also makes sense. Essentially, what you want to do is whenever something is not directly related to the user interface, move it outside of React as much as possible. Another example is something like state management, right? If you have complex client state management, put it outside of React. Use a state management solution like Redux or Zostad or something like that. Now, the third performance optimization tip for modern React is going to be to try to use server components whenever possible. Now, I know that server components, right, not every developer is liking them currently. I know that there's a lot of drama around that. I don't want to get into the drama. I just want to focus on the benefits that server components can add if you use them correctly and if you use them the way that they were meant to be used. Because the thing is, server components do require a different mental model of how React works, right? That's the whole point of modern React, right? This is now React on the server and it's completely different from the client, right? There's no more re-renders, there's no more hooks, there's none of that. And actually there's no more JavaScript, right? In terms of what gets shipped to the user. What gets shipped to the user is the actual HTML output of the function that was the component, right? Because components are functions, right? So that's a function that runs on the server, can be asynchronous, can do all kinds of cool things, and then returns some HTML that is then sent to the user. That's kind of the simplest way to think about server components. And actually, those are the very reasons that server components offer better performance in your React applications, right? So the fact that a component can actually run on the server, that means that all of the JavaScript and all of the dependencies and all of the things that it's needed to actually compute its output, the HTML, can run on the server and does not have to burden the user, the client, with all of that. That means that on the server, you can have any expensive libraries, you can do any expensive code that you want to. It's your server that is going to handle that, and whatever output that function produces, that's the only thing that is going to get sent over the wire to your actual users. So from a user perspective, that is really performant because they don't have to download a JavaScript bundle. They don't have to wait for all of that to load, right? To download all of these dependencies. The server does everything and just returns the simple HTML for the user, right? So that's already a huge benefit for server components, but that's not all, right? Because server components actually run on the server, there's no concept of re-rendering, right? They don't re-render. How can they re-render? Because they're on the server. There's nothing to re-render. The only thing that the user sees is HTML. So by the point that the user actually sees the HTML, React is kind of no longer there. It was run once on the server, at least usually, and that's it, right? They just get HTML. I know we're all used to basically having all of these re-renders and stuff like that because we've been working with client-side React for all of these years. But running on the server, there's no re-renders, which means that it's more performant, right? There's nothing that you can really shoot yourself in the foot with and have expensive re-renders or have like infinite re-renders, because that just isn't a problem in server components. So it is more performance. So it is better for performance. Now, this doesn't mean that you should now go and completely get rid of all of your client components and convert all of them to server components, because that doesn't work. That would not be efficient and that would break a lot of your application. Because when you think about it, right, because we have server components, right, we have no JavaScript bundle, we have no re-renders, so we also don't have any of the React features, like hooks, for example. We don't have any concept of state, right? We don't have any concept of effects, of memos and stuff like that. All we have is HTML. And the truth is, applications, they need state. We need to run effects, right? We need to have all of these functionalities there that are interactive. We need to listen to events, right? A button click, the user typing on an input. These are foundational parts of a application, of a web application, and you cannot go without it, right? So it's not about converting everything to server components, but rather using a mix of both server and client components and actually using each one for what it is good at. And that's where a lot of people unfortunately struggle with server components, because again, it is a skill that you have to learn and it is a different mental model, right? You have places for server components, places where it makes sense, and then you have places for client components, and orchestrating them together is a difficult matter because you have to learn this new mental model, and you can shoot yourself in the foot very easily as well, and you can actually, unfortunately, too easily run into worse performance if you're using server components the wrong way, which kind of attributes some of the drama and some of the pushback of many developers on server components. But if you truly learn and take the time to adapt this new mental model, I promise you, you will see the value in server components and you will actually get performance benefits of using server components if you use them correctly in the right way and also in the places that they should be used, and leave everything else to the client. And finally, the last point that I will leave for this video, because it's getting quite long already, and again, there's a full document in the first link in the description with a bunch more of these equally as important, totally for free. So just make sure to get on that. That is going to be to use transitions. So transitions in React are essentially ways to mark state updates. So we're now back on client-side React, where honestly a lot of these performance optimizations actually matter, and is to basically mark state updates as transitional, which means that they can be interrupted if something else has higher priority and should update earlier. And this is usually done through the use of the use transition hook, which basically will give you two properties. Will give you back a is pending property and then a function to actually start the transition. And then what you want to do is you basically want to wrap your set update, your state update, right? The set function that is going to update your state. You want to wrap it in that start transition, and that is going to mark the transition as being interruptible. And this is huge because we didn't always have this for the entire existence of React. This is a relatively new thing. It's not new in React 19, but it's relatively new in the grand scheme of React. And essentially what this allows you to do is to really decide which state updates are important and which aren't, because in a React application, some state updates are more important than others. For example, typing on an input, right? If a user types on an input, you want that update, the actual value of the input, you want that to be instant, right? You want that to be priority. However, the thing that the input might update, right, as a result of a different value in the input, for example, it's a search results, right? That is less important, right? Because you want, if the user types something, you want the input to respond immediately, and you can delay the actual updating of the search results because they're less important than the actual input. And this is huge for performance because it plays into perceived performance of your application, right? So how a user perceives the performance of your application, which ultimately is the only thing that really matters, right? That's why a lot of these applications use like really clever and really cool tricks to hide some parts of the application just to make it feel a little bit better for the user, right? Which ultimately is real performance, because if the user feels that the application is faster, it has better performance, then your application objectively has better performance. And transitions are a great way to do that. And unfortunately, in a lot of the code bases that I see and that I review, I don't see this hook and this concept being used that often. So no wonder why people are complaining about performance in React, right? Because they're not using the tools that React gives you to actually improve that performance. So if you haven't used transitions, do an audit of your app, look at some of the components that you're actually using and ask yourself if transitions are a good approach here, right? Go in the React documentation if you don't know about transitions, look it up, read up on it, get some knowledge, and then figure out if it makes sense for the specific use case, the component, the field, the input, whatever you're using, to use a transition if you're not using one. So there you go. These are 4 of the most important performance optimization tips in modern React, right? If you use all of these 4, you're going to see significant improvements in the performance and perceived performance of a React application, right? If you add the React compiler, you're going to see the biggest improvement for the least amount of effort. Putting things outside of React whenever possible does require more effort, but has huge benefits. Server components arguably has the most effort required because it requires you to adapt a whole new mental model. But again, there's value and there's benefits from doing that. And then transitions is something a little bit smaller, not to be used everywhere, but it's still very valuable and can make a significant impact. So if you want the full list of all of the other performance optimization tips, once again, all you have to do is join the Import React newsletter, which is my newsletter all about React, which is of great value anyways, and it's completely free, using the first link in the description down below. As soon as you join, you're automatically going to get the document of all of the other super important performance optimizations that every React developer has to know. So that's it for me. That's all that I had for this video. If you've enjoyed it, of course, leave a like, subscribe. My name has been Kozin. This is Kozin Solutions. Thank you so much for watching, and I will see you in the next one. Ciao, ciao.